Yes, I'm excited to finally give this webinar. I have been thinking for a while now about how to share some of the things I've learned over the last few years, especially about how to engage students in reading and writing in science classes, which tends to get ignored and tends to, if it's not done carefully and thoughtfully, put students back into their shell when what we want is to draw them out of their shell. So what I've put together are some resources and some stories about how I've succeeded in the past getting students to open up in discussion, and specifically how to do that with primary literature. So by primary literature, I mean things written by the original author. And I mean it in the broadest sense. So I'll talk about primary literature and modeling, and then how to incorporate this literature into board meetings, which already are Socratic in nature. And then I'll go with some examples, and there'll be an optional quiz. So if you want to get a piece of paper and a pen to score yourself, you can do that. And then I'll tell you how and where to find the resources that I've used. So the warm-up question is, think about who at your school teaches with any kind of Socratic discussion and or primary literature. And if you can think of someone right off the bat and you haven't done it yet, ask to sit in on their class. Things like, how do they arrange the desks? Or do the students sit at a table? How and where do they write which boards, and where do they post them around the room? How are students taking notes? And how have they allowed students to prepare for engaging in the discussion? You can learn so much about leading Socratic discussions just by going in and watching your colleagues for a few minutes. And then if you can't think of someone off the top of your mind, go find the chair of your English department. And I'm sure they'll be able to tell you who is doing Socratic discussions and when, because there likely is someone. So a little bit about me. I have, in a way, done a career in reverse. So most folks that I meet that are in science education have started out teaching and then have gone into research, and I went the other way. So back in the early 2000s, I was in graduate school, and I went to Clemson University for my PhD, and we got an NSF grant to travel around the world and collect insects and look at their DNA and look at their morphology. And we wanted to know how they were related and how those phylogenetic relationships allowed us to use them as bioindicators of water pollution. So we went to as many places as we could that had rivers and streams, and we collected bugs, and we ripped their legs off, and we sequenced their DNA, and we studied them. And this was what I thought I wanted to do for the rest of my career. So after I graduated, I did some work in DC, and then I started a collaboration, which is a whole other story, how that started, with some Iraqi scientists. And I wound up in northern Iraq in the Kurdish region as an assistant professor at the American University of Iraq, which was a brand new liberal arts institution. And I got a USAID peer grant with a couple of partners, local partners, and partners at Miami University of Ohio. And we ran a research experience for undergraduates. And what I discovered through all of that is that I loved teaching way more than I loved even my research. And I definitely loved teaching more than I loved managing grants. So when I went back to the US, things got a little dangerous in Iraq in 2014. That was when ISIS came on the scene. So field work was not as easy as it was before that. I got a job teaching and took some classes to learn how to teach younger students. 10 years later, I wound up teaching my son's third grade class in Louisiana. So the photo on the bottom right is my son, Josh. He's 10. And he and his classmates, this is a third grade STEAM class, and they are doing the Spaghetti Tower Challenge, which if you've never done that in your class is just a really awesome thing to do. So I've applied a lot of what I learned as a researcher to my teaching. And one of those things is adding primary literature to science classes to help students engage in discourse. and to give them excellent, rich resources to read and write about, in addition to all the empirical data and empirical evidence they're collecting from their labs. So this is just a short summary of where I've been and what I've done the last 20 years. My background is in biology, and my background is in liberal arts institutions. And I'm really proud of the A and the BA and the MA. I had to read and write a lot to earn those degrees. And that has given me a lot of wonderful experiences, and it hasn't limited me on my ability to engage in scientific research and teaching. Then after I did my dissertation, I was in the Smithsonian for a little while, and that is important to me because I got to do a lot of work in their libraries. Most of what I was doing was researching a beetle that nobody really knew anything about, and the only person who was an expert had died. So I got to spend 3 years researching old primary literature, mostly descriptions of beetles in languages that I didn't read. So I came to appreciate the value of older classical scientific literature, especially species descriptions. And then I married that with the latest research in DNA barcoding. So we were trying to match the DNA of these insects from all around the world with any known species description to try to tell if they were new to science. So then after I did that and I did my research experience for undergraduates, came back to the US, I pivoted to K-12 and have been teaching in the K-12 sphere ever since. I've been a modeler since 2016. I started with chemistry, and I've done a little bit of modeling biology, although I have not taken that workshop yet. I've done a little bit of middle school modeling, and now I'm teaching physics for the first time. I'm teaching at a private school, the Dunham School in Baton Rouge, and I'm teaching physics and anatomy and physiology. So these are some images of my 3rd grade STEAM class, and then I also taught 5th grade science at my son's school. And what I noticed about younger students is they loved whiteboarding. I brought the whiteboards into the classroom and they lit up, and they had no fear whatsoever at representing their thoughts multiple ways. The only thing I had to do was, navigate some conflicts over who got to use which marker. And then they just came alive. So I could put the board in front of them and ask them to draw a graph. I could ask them to describe their thoughts in sentences. I could ask them to draw, and they just soaked it up. And I thought, how does that compare to my experience teaching middle school and high school? Well, middle school and high school can be a lot more challenging to get kids to open up. Maybe you've had that experience. So 3rd grade and 5th grade, no problem with getting them to open up. As they get older, I think they become more self-conscious, and they, at least my students that I've taught, get really scared about saying something that they think is wrong. They don't want to give the wrong answer. Little kids don't care if they're giving the wrong answer or they're not. They just want to share what they're thinking. But when they get into 6th, 7th grade, and especially in high school, Socratic discourse can be terrifying to them because they want to get the right answer, and they want to get points, and they want to get a good grade. And giving them resources to help them open up is sometimes all we can do, and then give them time. So again, why am I talking about primary literature? It's to help encourage and engage middle and high school students. You probably could do this with younger students too, but I didn't really try to do this with my 3rd and 5th graders. Primary literature facilitates multiple representations in students, especially when you can put literature in front of them that is examples of exemplary descriptions of nature, maps, especially annotated maps, illustrations and descriptions of experiment techniques, any kind of diagrams. And these are often less intimidating than just giving them the equations off the bat, which we know as modelers already, and even giving them graphs. If you can lead them into the modeling cycle with more observational, descriptive activities and descriptive discussions, then they tend to be less intimidated when you get to the quantitative nature of the modeling cycle, especially when you apply the model to solve problems that they've never seen before. All right, why do we care? So first of all, I would make the argument that a lot of folks in the liberal arts world make, that literature has intrinsic value to humans. and we should study it just because of that. But that's hard to convince an administrator to care just because of that, right? They may, but they're up, they're up against deadlines and they need funding. But you've probably heard or seen the recent NAEP scores from the nation's report cards, and reading scores were down in all percentiles. The only group that did not show a decline were students who had said that they enjoy reading outside of school. That group that still reads a certain, I forget how many hours outside of school, their scores didn't drop significantly, but in every other category, they dropped. So students need more practice with reading and verbal reasoning, whether that's oral or written. And I don't think it's fair to just leave that up to the English teachers or the ELA teachers. I think that we can really help students recover from COVID learning loss and just become better readers and writers and verbal reasoners if we can support this type of work in our science classes. And the modeling cycle it's already primed for this. I have not had to change anything about the modeling cycle other than to allow more time to add literature. So here's an example of what I mean. This is a whiteboard from a 10th grade chemistry class. They were asked to light a candle, make some observations, and do a storyboard before, during, or after. So they're already putting ideas of what they think is happening with the candle. And they're drawing graphs, they're representing their thoughts multiple ways. And these are students that have already had several years of modeling. These are not students who are brand new to modeling. And what I hope to, if not convince you of, at least encourage you to consider that primary literature enhances this practice that we already do as modelers. So I'm going to give you 7 examples. And so here's the quiz part. If you want to participate, for each one, you get a point if you can guess whose work it is, and you get another point if you can approximate when it was published. I'll give you all a minute to think about this one. Whose work is this? All right, give yourself a point if you recognize this is Darwin, his first notebook on transmutation of species. And a board meeting prompt that you could give with this is, what does Darwin think? Because he starts with, I think. And then he draws a picture, and then he writes down his thoughts. And I started with Darwin because that was the first primary literature I ever put in front of students. It was a 7th grade class that I was teaching in Arizona. And I wasn't sure what they would get out of it. It was not on the origin of species. I would not give that to 7th graders, but it was one of Darwin's letters from his adventures on the Beagle. And they loved it. And we had a very interesting discussion reading his letters and reading his descriptions of what he noticed. All right, here's the second one. All right, give yourself a point if you guess this is Lavoisier. Both Antoine and Marie-Anne, his wife, she did almost all of his illustrations. A board meeting prompt you could use with this is describe what you could measure with these instruments. And this is something that middle school students could do even without reading the text. You could start just by showing a picture. The same way artists talk about a painting. Okay, here's number 3.
Your mobile device is still in the vehicle.
Whose work is it, and about when was it published? All right, this is Michael Faraday, and it was published in a lecture series that was spanned. I don't know exactly which year this lecture was published, but it was in between 1848 and 1860. These are the famous Faraday lectures. And it was his lecture, The Chemical History of a Candle. So a board meeting prompt, you could just ask students what is happening in this scene and have them make a whiteboard of it. So here's an example of that whiteboard I showed you earlier. If they had already made this board in Unit 7 of the chemistry curriculum and you're studying combustion and you've just gotten through the combustion lab, this would be a great place to read some Faraday, or at least look at some of the diagrams in his writings. You could ask them, how is your candle similar to or different from Faraday's? And that can lead to a great discussion. All right, now we're getting into some text from primary literature, and these would now be things that would be more appropriate for high school students. So I'll give you a minute to read this over. All right, any ideas yet? Whose work is this? Hopefully you are recognizing some of the letters and what characteristics this scientist is talking about. All right, did you guess this is Mendel? This is the famous Mendel paper, his experiments in plant hybridization. This is one of my favorite things to read with ninth graders. We read experiments in plant hybridization at the same time as we're breeding Wisconsin fast plants. I have not done this as a part of the formal biology modeling curriculum yet. So this was just part of modeling, or part of a biology curriculum that we used some of the elements of modeling, but we hadn't adopted the full AMTA curriculum. So I'm not sure where this exactly would fit in biology, but it would be whenever you're doing genetics and Mendelian genetics. And I highlighted some terms in bold that you could have them on. So 2 expressions for characters A and B are combined. And then talk about I just asked, what does he mean by classes of series? What does he mean by A and B? Is this an algebra equation, right? What does he actually mean by this? If you have been doing genetics experiments, you could even have them combine this with their lab. Left is a whiteboard that some ninth grade students did. We just asked them to summarize what they had done so far in their Wisconsin fast plants experiment. So they're already representing their thoughts verbally, and then the picture in the middle is them growing the fast plants, and the picture on the right is the I think that's the F2 generation. And so they have their data, and they have their boards, and they have their plants, and they have Mendel. And we didn't get through the whole paper, but we got through probably half of it. We at least got through his description of his experiment and why he did what he did. And it was a wonderful seminar. All right, so here's one from the chemistry world. You can probably tell by the very last word. Okay, and anyone guess Marie Curie? So this is from her 1911 Nobel lecture, which she entitled Radium and the New Concepts in Chemistry. And I just love how she reinforces the idea that is at the heart of the modeling cycle, that theories allow us to make predictions. Right? She says the most brilliant triumphs of the theory is the prediction that. So if you are already having a discussion about how, say, atomic theory, or if you're talking about atomic theory, you're talking about periodic laws, and you're already students in a discussion of what's the difference between theories and laws, this lecture, even if you had students who have had drama training read parts of this aloud in class, it gives them something else to make their discussion deeper and richer. All right, we got 2 more. Number 6 is another classical paper, and then we'll have one modern example. All right, so I'll give you a minute to process this one. Again, the last few words might give it away. All right, give yourselves a point if you guess this is Mendeleev. This is his 1889 Faraday lecture, so decades after he published his first versions of the periodic table. And his lecture was entitled The Periodic Law of the Chemical Elements. What I've highlighted in bold is something that matches very well with the lab that we do in Unit 11 of the chemistry curriculum, which I always have the hardest time getting to Unit 11. But this is my inspiration. I have to, whatever I do at the end of the year, we have to do this lab in Unit 11 because it is such a powerful way of seeing how Mendeleev's periodic table isn't just something that hangs on the wall, right? It has behind it, and it is, again, part of the discussion that we have continuously with students of where theory and law meet. So this is a picture. I didn't get permission from my students to use this, so that's why their beautiful faces are little thought bubbles. These are the whiteboards that they made, ionization energies this is Unit 11, Investigation 1 or 2. Okay. So if you had them this lecture, and this is a difficult lecture. You know, this would take some time to read this, or you could read it to them. And then you just say, what does Mendeleev mean when he says that because the periods do not contain the infinite number of points constituting a curve, but a finite number only? You could pause there and ask students, draw what you think he means there. What is the difference between an infinite number of points that constitute a curve and a finite number of only such points? And if you pause then and had them draw some whiteboards, that right there would lead to an interesting discussion, and it would help you see if they understand what he's talking about. Okay, so those are more examples from more classical literature. But what about modern primary literature? So modern primary literature has it all. Modern papers integrate graphical, right, mathematical, diagrammatic, and verbal representations. It's why they are both so interesting to read and so difficult to read. And if, at least for me, the times that I've just given students a modern paper, you know, say from last year's Science Magazine or Nature, it's really intimidating to them because it's everything all at once. But there is this wonderful site. I don't know if anybody has been to this before. I'm just going to pause. Can you, I hope you guys can still see that. Yes. So this is a site from AAAS, and it's called Science in the Classroom. It's a collection of scientists who have volunteered to annotate research papers and teaching materials specifically to be used in classrooms. This would be appropriate mostly for high school, but there are some papers that you could even give to middle school students. And the one I wanted to show you is this one under featured activities, Metabolic Middle Ground, Evidence for Mesothermy in Dinosaurs. This is a really cool paper. Each one that you look at in the collection will have an editor's introduction. Then you'll see the resources for teachers on the left. So you'll get you can download the paper. There's some activities that you can do. There's an educator guide with more information about the science itself. You can download the PDF and go to related content. For students, what's really powerful is they can turn on different learning lenses. The first one is the glossary. So you might ask, well, why can't students just look things up, or AI can do this? These terms, these glossary terms were written by the volunteers, and they give context of what this term means within the paper, not just across all of biology. So it really helps the students narrow down and engage in the beginning of the paper. Because if they get words that are really difficult right in the beginning of the paper, they can shut down. And then it's really hard to encourage them to keep reading. So if they turn on the glossary right off the bat, that again can make it more engaging. You can highlight previous work, authors' experiments, conclusions, and then some other connections to things outside or beyond the scope of the paper. And it turns them on throughout the whole paper, right? You can click on them and even get more information. This is all done by the volunteers through some support. I think this was also from an NSF grant. There's also videos, the Howard Hughes Medical Institute Bio-Interactive project. So there's a lot of great resources from HHMI. And then what is also very cool, and this gets back to multiple representations, is that if you go down to some of the images, so not this one in particular, it gives you different panels. And then if you scroll below, you get discussion questions. So you could engage students in any kind of discourse, Socratic or not. You get questions, you get graphs that you can talk about, and then there are answers. So if students are really just concerned with what's the answer, say, look, we know what the answers are. Let's talk about why these are the answers. On making some sense out of the answers rather than be worried about what the answer is and how many points I'm going to get. So you can look through these papers. There's so much information in these papers. And I have used, I've used one on the brain. There's one on the effect of sleeping in the brain in this site. And I've used that in a 9th grade class before. And it was a wonderful discussion. Okay, let me get back to the presentation. Okay, so here's a modern paper. Last quiz question. Whose multiple representation diagram is this? Some DNA, we've got some gel results. Give yourself a point if you guessed this was the CRISPR paper, the 2020 Nobel Prize from the Data Lab. Go to the Nobel Prize website, which I'll show you in a minute. You can see her give her Nobel Prize lecture about what her lab did and how they came up with this technology, and it is absolutely wonderful. So even if giving students primary literature, if that's maybe a step too far to start with, you can start with just showing them a video of a lecture of a Nobel Prize winner. And you're not having them read the original CRISPR paper. That's probably not what I would do unless I had very advanced students who really were interested in research. The Nobel Prize lectures are geared towards a more general audience, and their point is for them to be engaging. It's their goal when they give their Nobel lectures is to not only highlight the science, but the relevance and to make it delightful for audiences. And her lecture truly is. Okay, so did anybody get all of them right? Half of them right? Okay. These are ones that I would not have guessed. I definitely did not. I think I maybe knew one. Okay, I knew Darwin because I took a lot of Darwin classes in grad school, but these were not ones that I learned about until I started modeling and until I started trying to infuse primary literature into modeling discussions. So these links are, I think I may have missed the Mendeleev paper, but all of the rest of them are in the document that I put in the chat, and I'll put that in at the end of the webinar as well. And they are all free. I'll show you at the end that has a small fee, but all of the rest of these are free. You don't have to pay to download them, and you don't have to pay to use them. Most of them you don't even need an account to access. So they're very easy to use, and you just try it out. First resource. These are books. So there are some free resources from the Great Books Foundation. The books themselves you do have to order. And I think I just ordered the physics one, the What's the Matter. I've just started using that one this year. I think it was somewhere around $30 to $50 for the book. I think closer to $30. The biology book, The Nature of Life, I have used that with 9th grade. There's 2 new editions of that now. So they've turned the 1 edition into 2. And there are fantastic teacher resources in these books. They give you discussion questions. They give you questions that help students learn how to annotate text, because you may or may not have students who've learned how to do that by the time you get them in modeling. Some of them will know how to do that very well. So again, I've used The Nature of Life, and I'm just using the What's the Matter book this year. I just gave my senior physics students Aristotle's Four Causes reading a few weeks ago. And the 2 reactions, one student was reading it and she said, Dr. G, Aristotle, he thinks too much. But then she smiled and kept reading. And then my other students came in and they were all flustered. I don't understand anything. I don't understand anything I read. Why are we reading this? And as soon as I sat them down in groups of 3 and I put a whiteboard in between them and I assigned them the content questions that were in the book, not things I came up with. And I said, all right, you 2 do 1 and 2, and you 3 do 3 through 5. And as soon as they did that and they broke it down for them, we had an amazing discussion. And the purpose wasn't for me to teach them Aristotelian philosophy. It's not a philosophy class. It's a physics class. But it engaged them in thinking about how Aristotle considered knowledge of the cause and what he considered scientific knowledge. And then the next readings that we'll do in the What's the Matter book are Galileo and his ideas about motion, and then Newton and his ideas about motion. And those may be the only 3 that we do all year, but at least it gives them a connection to the ongoing discussion that's been going on for millennia about what is nature made of, things move, and why do things change. I have not used the Keeping the Whole readings in environmental science, but from what I have used so far, it's probably very good. Right, then here's Faraday's Chemical History of a Candle. These materials are all free unless you want to pay for the paper version of the book, then you can order it. This is Dr. DaCosta, Hammock and DaCosta out of University of Illinois, Urbana. They have turned Faraday's lectures into videos with wonderful, wonderful demonstrations. Things lighting on fire, things exploding, things freezing, things that I would never feel safe doing in a high school chemistry classroom. Something would go wrong. And not only that, they have edited lectures to about a high school reading level, and they've provided a whole series of experiments and teacher notes so that you can follow along each of Faraday's. Originally, I believe he had 5 lectures, and they've condensed them into 4. I have added a few of these, some of the experiments, but the readings, I've added links to them in some of the revised middle school materials that if they're not published on the AMTA website yet, they will be soon. So look for the AMTA middle school materials, the mega unit about water, and you'll find more information about how to use Faraday's Chemical History of a Candle. There's also a link to other Faraday lectures. So after Faraday gave these lecture series, they named the lectures after them. Sometimes they also call them the Christmas lectures if they're being given by the Royal Institution. Here's the Science in the Classroom site, which I have already showed you. This has been out for a while, and I don't know if they're still doing more papers, but they are already very good. Oh, the unit is posted on the AMTA site. Okay, great. So you can go to the AMTA middle school site, back up, and find the new materials on the mega unit on water. I can't even remember what we wound up calling it other than mega unit on water, and find Faraday's Chemical History. Right, then here is the Nobel Prize lecture page. So if you just go to nobelprize.org and look up the Nobel laureates, have to be classical authors. It could be modern Nobel Prize winners. Most of them will have not only facts and biographical information, they could have a documentary, and most of them will have the transcript of their Nobel lecture, as well as the banquet speech that they gave. Obviously, someone like Marie Curie is going to have more resources than maybe some of the modern authors, but the Nobel Prize website, they really put a lot of information on there that students can look at if you're looking for them to do a project. This would be a great way to get them engaged in some research. Right, the last thing I wanted to tell you about before I leave time for questions is, so what if you're worried about students who have modifications or students with reading disabilities, or how do you work with your special education, your ESS team? I am not a special education teacher, but I can tell you that the first thing that my colleagues always ask me is, well, what's the reading level of the text? And at first I had no idea what they were talking about. I don't know what the reading level is. What do you mean? One of the ways that you can judge what grade something is appropriate for is by a Lexile score. It's not the only way, but this is one that's used very, very often, especially for modifying reading for students with disabilities. This one is hub.lexile.com. I bought a subscription. It was $17.99 for the year. And it gives you, I think, 50 searches a month up to a 500-word limit. So you can take an excerpt of anything you want to give students, and it will give you a Lexile score, a range, an estimated range. And then you can see on the left, here's the 50th and 90th percentile. This is the beginning of the year Lexile scores. So if you're talking about high school, you're talking about things that are starting in 1,000 to 1,100 to 1,200 range, and go all the way up to I think the maximum score is 1,600, at least for the high school students. So here's an example. This is Lavoisier. So the illustration that I showed you earlier in the quiz, that is from his famous chemistry, the first chemistry textbook. This is some of the text that is in that book, and I did just a snippet, just 123 words, and it came out to a Lexile range of 1,010 to 1,200. So this is squarely in upper middle school, ninth grade range. If you have younger students, you may want to give them less of it. If you have ninth, definitely by 10th grade, they should be able to read parts of Lavoisier. Maybe not the most technical parts, but at least where he's making observations and his ideas about what those observations mean. It will give you information like the longest sentence, the indicators, how they came up with the Lexile range and some of the vocabulary. And then what's really interesting, they give you some recommended books. So the books that are most similar to Lavoisier is a book about trolls, The Jungle Book, and a book I had never heard of before, but I want to look up, The Voice That Changed a Nation, Marian Anderson and the Struggle for Equal Rights. So students can get an idea of what other books are at this level, and then you can recommend them to them. All right, at the other end of the scale, Marie Curie's Nobel speech is something that is for advanced students. This is a Lexile score range that is on par with Aristotle. That was the first book that came up, was Aristotle's Physics. So this would be something to give them in addition, like if you are teaching physics or chemistry and you want to use the great books, What's the Matter book, this lecture would be about the same level. But then it's also similar to the History of Rock and Roll and the Legend of Sleepy Hollow. Aristotle is pretty dense, and I think it was 4 pages at a time. For Faraday, the lectures are more, I'd say it's more 8 to 10 pages at a time, and I break it up so that they're not reading more than that in a night. So I would say they're anywhere from 4 pages to 10 pages, depending on how dense it is. I also don't expect them to do it on their own at home. I give them a lot of time in class to read as well. The full papers range, some of them are short. I've read Watson and Crick's paper, and that's 2 pages. The Faraday lectures are probably in the range of 20 to 30 pages. Do I collaborate with your history and English teachers? Yes. So the school I'm at now, the Dunham School, uses a method of discussion. I don't know if it's strictly considered Socratic. It's called Harkness, Harkness, and it was devised at Phillips Exeter Academy. Apologize, that's my dog that's whining. So Harkness is very similar to a Socratic discussion and how it's set up. You have students sitting around a big table, and the teacher proposes a question and tries to students actually as little as possible. They let the students drive the conversation. So I have been working to get Harkness trained. And what's really exciting about the school I'm at is they have trained their humanities teachers. And in the spring, they're going to start offering Harkness training to the science and math teachers. So I'm hoping to have a Harkness physics class by the end of the year. They're always happy to help me, English and history teachers. I'm curious, have any of you all ever led a Socratic discussion with any primary literature?
You might have to ask that question again. People are popping in now.
Okay, welcome back. So I'm curious who has tried to do a Socratic discussion, either with the modeling cycle or not, with any kind of primary literature. Has anyone tried it before? It was a little terrifying the first time I did it. Be honest about that. And I didn't feel like I knew at all what I was talking about, but sometimes I'm like, I'm not an expert in Aristotle by any stretch of the imagination. I just tell myself the goal here is not to make them experts in reading scientific primary literature. It's to get them talking. And it's the same goal we have with modeling instruction. It's to be able to see what's inside their head and give them examples of how other scientists have tried to take what's inside their head and put it down on paper, or give it to the community as a lecture. And if we're wrong, okay, we're wrong. I don't grade them on how well they analyze any of these papers. I may give them participation grades, and I'm not having them write essays about it. I'm not an English teacher. I don't grade essays. But I might ask them a question on a test, or I might have them put something in a lab report. You know, Faraday found this. What did you all find in your combustion lab? Are your modern results consistent with what Faraday found, you know, a century ago? And what does this tell us? And if you just put a whiteboard in front of them, you'll have things to talk about.
So,
The last, sorry.
no,
I encourage them to start with a diagram, start with what they're comfortable with modeling. So by the time I introduce primary literature, they already know what the expectation is for multiple representations. And they will inevitably start with a diagram. Then I will ask them to add more verbal description of what they're drawing, or I might ask them to pull something from the text and just copy it. Even if they're copying it word for word and putting it on a whiteboard, that's getting them getting exposure to the words of great thinkers. And some students, this is easy to do, and some students, it's not easy for them to do. Just like anything else we do in modeling.
mhm.
Another thing I'll share is that some of the times where this has come in really handy for me is when we have those, you know, weird days because the schedule is off and there's a, you know, a homecoming pep rally and one class has something and another class doesn't and you get off, or there's a, you know, a Friday before a break and you don't want to start anything new. Like a Friday before a break is the perfect time to just do a Socratic seminar and say, all right, folks, this can only help your grade. This is going to be hard. We haven't done something like this before, but we're going to read this together and we're going to talk about what we think it means. And here's a whiteboard. And if they do well and they participate and they make contributions that make sense, you give them an extra participation grade, or, you know, however it works in your grade book. And then you don't have to occupy them for, you know, a whole class period where you've already finished something and you don't want to start something new, and you don't want to just throw on a movie without a purpose to it. So I'm curious, would you all be interested in a teacher that Socratic seminar with primary literature? Is that something that you think teachers would be interested in? It's something I've thought about doing, and it's something that I didn't think we could do on Zoom, but I am in a Socratic discussion once a month through St. John's College, which is a great books program. The last night we did the Canterbury Tales, and I was way out of my depth. I'm pretty sure everybody else in that seminar was, you know, a literature major. And I was intimidated and had a hard time speaking up, but it was good because it reminded me this is what my students probably feel like in class. And I made a few points, and I'm getting to know the other participants, and we're doing it on Zoom. And it works fine. You know, of course it's not as fun as in person because you can't go out to happy hour afterwards. But I can tell you from experience that being humbled in front of great work of literature is something that's good for all of us. And it's okay if we don't understand every word of it. We can model humility for the students and say it's okay if we get to the end of this and we are left with more questions than we started with.
I like your idea. Would you want to do like a follow-up webinar to this one where we're actually?
Oh, that would be fun. So like pick something to read and actually do a Socratic seminar. Oh, I would love that.
I think that would be awesome. That's just me.
What
does
do you think
everybody
we
else
should
think?
do? Did any of my 7 quiz questions whet the palate or whet the appetite?
I'll let everyone else weigh in on that. I don't know if
Maybe
they're.
we could do a survey.
Okay.
Faraday is fun. That is my single most favorite work to teach because it spans every single science. He starts with chemistry, he then goes into some thermodynamics, and he ends with paralleling the combustion reactions of a candle to respiration
Wow.
and photosynthesis. So if we could do the lectures, at least some of them, and homework or pre-work could be for teachers to watch the videos, then that could be fun.
Does anybody else have any other questions for CJ?
Do you have most of the sources that you showed were sort of more biochem-ish? I'm wondering if you've done anything that's more physics related.
Not yet, but by the end of the year, since this is the first year I'm teaching high school physics, I'm finding new things every week. The What's the Matter book is pretty fantastic.
Yeah.
It goes mechanics, mostly mechanics in the first half of the book, and it goes all the way to Faraday and Maxwell and Einstein by the end.
When you're using the What's the Matter book, are you just photocopying, scanning something out of it for the kids, or how are you using that as a resource with your students? Or are you not?
So I'm doing just snippets and going from the fair use policy. I can't photocopy the whole book for them. That would break
Yeah, of
copyright.
course.
What I would love to do, and I'm going to float this idea, is to buy a class set. I've also done that, where we have a class set and we're only reading them in class. Buying books for all the students would, we're back to the whole idea of buying textbooks, and I know schools don't want to do that anymore, but having a class set would at least allow students to engage in the reading, and then they can't take it home, so they can't do it for homework. With all the other resources, they are open access.
Okay.
Into those issues. Another thing I have done to get around, not breaking copyright is I've looked at reading, and they're all the sources they're pulling from are
know what you mean.
old enough that you're not breaking copyright if you find them on the public domain. So I might go to the public domain, like I've done that with Dalton's new system of chemical philosophy, which you can just find on Google. What is it called? Google Books. And then I have to do some more work, but I'm not putting the primary, I'm not photocopying the book. I'm giving students the link to the primary reading and telling them, read this paragraph or this paragraph. And then our class set of books is what we use that has all the questions in it.
Thank you. This sounds really interesting. I'm definitely interested in trying some of this out in my classroom.
You're welcome. Let me know how it goes. I would love to be part of that. I don't know, does IB, do they highlight any kind of reading of scientific literature?
Not specifically reading, but the kids have to write a lot, and I think it's hard to write if you don't have good examples of reading. So I mean, I think that's something my department has been looking at. How can we incorporate more reading, because our kids don't read at all, and also most of our kids are not native English speakers, so that's a bit of a challenge for them as well. And I think that this could be a really interesting way to bring in some primary sources and have them look at that, and then also just have some better models of this is how other people write.
One of the reasons I like the classical literature is because their papers were not, the goal of their paper is not the same as the goal of a modern author. A modern author is, get it out there, get the graphics there, do just enough writing, right, to get it published. They're not rewarded for delightful writing. Whereas if you read something that was written in the 1800s, if you can kind of get past the, sort of outdated prose, they write to be engaging, or they're writing letters to each other.
Yeah.
So they're more interesting to read than a modern paper if you're not already a research biologist or a research physicist or research chemist. Right? To us, modern papers are interesting, but kids are like, what is this? Why are you giving me this paper?
Well, I mean, as I'm sure you know, because you also got a PhD, you have to learn how to read a modern paper. So yeah, I can see the benefit of using something that is more engaging and maybe not quite as dense.
And there are parts that you can highlight for them and help them learn how to annotate. I think one of the most powerful ways to teach students how to write better is to teach them to annotate, because then they have to look for not only the text that helps them understand, but why is the author using that text in that way and in that order. And that's what they're being asked to do when they put together an essay. So I would start with Faraday. You can watch some of the lectures from Hammock and DaCosta. They're really wonderful. And they're not very long. They're, 15 minutes ish. And then so watch them. I have my students watch them once without the text in front of them, and then we watch them again with the text in front of them. And then I have them read it. So we get 3 run-throughs. And it doesn't take, if the first video is between 8 and 15 minutes, and then I have them watch it again with the reading, and then or I have them do that for homework, you're not taking hours and hours out of class time that you probably don't have. You're taking more like 20-minute snippets, which is really all they can process anyway. Is reading for more than 20 minutes is hard for most readers.
Yeah, that sounds really cool. Thank you. That's a really interesting idea.
I'm curious what you'll think of the environmental science book, and if there's anything in there that is more geophysical or chemical, or if it's all environmental biology, because I haven't looked at it. There be anything that would interest you?
Yeah, that would be interesting to see.
Thank you so much, CJ. I'm just so impressed. I did put a link in the chat for anyone that needs a certificate of attendance for PD purposes. If you could fill out that survey. It also just asks you a couple quick questions about the webinar itself. And we would really appreciate your feedback. So I just want to thank CJ again, thank everybody that's here for their perseverance with the technical difficulties. And I will edit the recording and send it out to everybody.
Thank you, Sue, for hosting, and hope everyone has a good night.
Thanks, everybody.
Thank you. Bye.
Thank you.